Good evening. In the following presentation, I'm going to present to you how to use Ethernet, the design software to supply water to 5 townships. So Ethernet is a software that is developed that can help you to design for the pipes, the sizes, and as well as also for parameters like velocity, flow, and pressure. The design is meant for various townships from township 1 up to 5 as laid out here. The good thing is that between the townships, there is a hill, which is a good place where one can position the reservoir. Because if you can see in the following slide, where the reduced levels are given, all 5 townships lie lower than the hill. So in this slide, uh, the source of water will be that river, Nyangwe River, which is about 1.5 kilometers away from the bulk storage reservoir. Water will be drawn from the river, pumped into the water treatment plant, and also that will be pumped up using the pumping main into the water tank. And from there, because the hill is situated uphill, it will flow down through the force of gravity. So it's not going to be pumped, but it's to supply all 5 towns. The project deliverables are to come up with the correct pipe sizes. That's to get the pipe diameter using the Ethernet software by doing so many trials. Also to get a sufficient flow rate, which must not be more than 1.5 meters per second, and then the adequate flow velocity, and then there must be a sufficient pumping head so that there is always constant supply without any shortcomings. The given data, the information that's known to us is that the demand must be met continuously for 8 hours using a pump curve to supply at 595 liters per second with a given head of 75 meters. And the required storage for a bulk storage reservoir should hold 10,444 cubics. The total demand was calculated for each demand center, and it has come to the equivalent of 10,244. But if you take the 12-meter high reservoir, which is 34 meters in diameter, that gives us 10,895, which is more than sufficient. So the total demand as per all 5 town centers is enough for the required volume. We have used Hassem-Williams head loss formula, which is an equation for calculating head loss in pipes due to friction, and this equation relates flow of water in pipe with physical properties of the pipe. Then the Ethernet design is as follows, where using the given dimensions, the links which actually represent the pipes were mapped as per and the nodes were also mapped representing the various towns. Then in order to have a pump with a good performance capabilities, the parameters were inserted in the Ethernet, and that is what we got as a pump curve for pump 1. So there's also a similar one for pump 2. And on this slide, we can see that when we got the successful run after so many trials, the pipe sizes were determined. All the gravity mains are 950 millimeters in diameter, and the pumping mains are 1,200 millimeters in diameter. And where the required velocities are also, as you can see here in the color coding of Ethernet, it lies between less than 1 and so basically the important thing is that the yellow block here represents about 1.5 to 2 meters per second. So looking at the color of these pipes, you can see that our velocity is within the required 1.5 meters per second, which is actually below that. So there's no color that is either red or yellow, so our velocities are fine. Then the hydraulic profile for the pumping main, that's for pipe which takes water from the water treatment plant into the bulk storage tank is shown here. And as per the figure, you can see that it actually gives a uniform flow from 0 hours up to an extent of 72 hours. Then all flow velocities were also worked out for all pipes, but because for the representation we just take the one gravity main, which is the pipe that takes the water off from the bulk storage tanks towards the first node. And also you can see that the demand is met and the flow pattern is very much uniform over the entire period of 72 hours. Then there's inclusion of the slide that shows the pressure for node, bulk storage tank, and in a conclusion, as we have come up with the correct pipe sizes, and also that our velocity is within each, and that the volume meets the demand, and we got a successful run from the trials. It's recommended that the municipality can go ahead and implement the infrastructure for the water supply as per this report. Thank you.